Okay, today we're going to talk about greatest common factor and how to find what is the largest term or largest item that I can take from each term in a polynomial. So, for example, we have a 3x squared, a negative 9x, and a positive 18. So the largest number that goes into 3, 9, and 18 is 3. So 3 is going to be what I take out of or divide out of this polynomial. So how we do that is we take each term individually and divide out of 3. Or you could think of it as multiplication. 3 goes into 3 how many times? 1. So the only thing I have left over after I take out this 3 is the x squared. In the same way, what about this negative 9x? Negative 9x divided by this 3, or 3 goes into 9 3 times, so I'm going to have a negative 3x left over. And finally, 18 divided by 3, or 3 goes into 18 6 times, so I have plus 6 left over. For right now, this is all we're going to do, but what I want you to see is that if you were to go through and multiply or distribute that 3 back in to this polynomial, you would get our original. So 3 times x squared is 3x squared. 3 times a negative 3x is a negative 9x, and 3 times positive 6 is positive 18. In the same way, it can not only be numbers, but it can also be variables. So here I have 4 x's, here I have 3 x's, and here I just have 1 x. So the most x's that I can take out of each term without going over is going to be 1. So whatever my lowest exponent is the most that I can take out of each term. So when I do that, I'm going to bring out this 1x. Now, if I had 4 x's and I'm taking 1 away, then I only have 3 x's left over, because x times x to the third gives me x to the fourth. And then if I had 3 x's but I take 1 away, then I'm left with this negative 5x squared. So 3 x's, take 1 away, I'm going to have 2 x's left. Now here, if I have 1x but I'm taking that x out, that means I have no x's left over, but I still have this plus 6 left over. So this would be our answer. And again, if we distribute or multiply that x back into the set of parentheses that we have, we would get back to our original problem. Now with number 3, over here in blue, sometimes with greatest common factor we have just numbers, just variables or letters, but sometimes we have both, so we have to look for both. Now, looking at this quickly, it looks like that 2, I made a mistake. It looks like 2 goes into all of them, and you would be right. So I wanted that to be a 16. However, a number larger than 2 also goes into them. So in this case, 4. 4 goes into 8, 12, and 16 evenly, and that is the greatest or largest number that goes into all of them. So if I factor out a 4, I also have to look at the variables. I have 3 x's here, 2 here, and 1 here. So that means they all have at least 1 x in common. So I can take 1 x out of each of these terms without going over. So my greatest common factor in this case is a 4x. Now I have to take that out, divide out each term by a 4x to see what I have left. So what times 4 gives me 8? Oh, that's going to be 2. If I have 3 x's here and I take 1 away, I have 2 x's left over, so 2x squared. And again, just a quick check, 4x times 2x squared is 8x to the third. And then minus, how many times is 4 going to 12? Well, that's 3. But if I have 2 x's and I take 1 out, I'm left with 1 left over. And then finally, plus, how many times does 4 go into 16? Well, that would be 4. But again, if I had 1 x only and I took that x away, then I have no x's left over on the inside.